This is for Year 12 Further Maths. It's the extended response question 6 from the Chapter 10 review. Okay, so Rosalind earns an annual salary. Annual means yearly salary of 54,200, which is paid monthly. Okay, so she did not join the super fund until her 37th birthday. She now pays 7% of her gross salary to the super. Her employer contributes, so it's a compulsory contribution, a further 14%. So, how much is she contribute her monthly income to her super? It's 7% plus 14%, which is 21%. Okay. So, what amount of money is placed each month into her super fund? Okay. So, if I go A, I know that the monthly salary is equal to 54200 divided by 12, because 54200 is the yearly salary. Okay, so if I were to get the monthly salary, I would need to go 54200 200 divided by 12, which is that amount. Okay, now we know 14% of that, so I'll just write 4516.666, 4516.666. So this amount goes to this is her monthly per month. So monthly salary is that per month. Now we know that 21% of that goes to the super fund. So 21% of this one, 21% of 4516.66666 equals. Let's see how much actually goes to her super fund. So if I go that number, what I have there multiplied by, so 21% of that, 21 divided by 100, I get 948.50. Okay, 948.50 goes to super per month. Okay, so 948.50 is going to super per month. How much would she have available on her 60th birthday? Okay, so first things first, we got to reread the question. 37. She starts on her 37th birthday. We want to find the amount that goes to her 60th birthday, and we're just doing compound interest. Okay, so compound interest, assuming that we're making constant contributions of 948.50 per month until she's 60. So between 37 and 60, that's how many years? That's 23 years. So 23 years, we're going to use finance solver just because it's easier. So how many years is that? 23 years times 12. The interest rate is 4.2% per annum. The principal value is 0 because we didn't put a lump sum at the beginning. Okay, we're just making constant deposits of 948.5 into the account. Payment 948.50, and P1CY12. I'm solving it and I get this amount. So 439,829.26. 439,829. So 439,829. Let's go. What's the decimal place? 0.26. So that's how much she has account when she's 60, or predicted to have when she's 60. Suppose that Rosalind retires at the 60 years age. She placed her superannuation in a perpetuity that will pay a monthly income without using any principal. If the perpetuity pays 4.25% per annum compounding monthly, what monthly payment will Rosalind receive? Okay, it's perpetuity. So remember, for all perpetuities, I want to use a formula. D equals R on 100 times V0. Now, what am I trying to find? what is the monthly payment? Okay, so you're trying to find the D value. My R value is, it pays 4.25% per annum compounding monthly, so you need to divide that by 12. Okay, R is 4.25 divided by 12, divided by 100 times V0. V0 is what your amount was from the age is 60. So 439,829.26. So once we get that, we should get our D value. Okay, so I'm going to use the finance solver screen to help me use this calculator. So I'm going to multiply this amount by 4.25 divided by 12 divided by 100 times, I don't need to times it because I've already times it here. Okay, enter, and I get 1557.73. 1557.73. Okay, I'm not sure if the textbook rounded to the nearest whole dollar, but it's around these two values. So hopefully that gives you an idea of what's going on. I think the tricky part, the thing that caught most people out was firstly that you need to know it's 21% of her monthly salary, so you needed to convert the salary to months, and then you're taking 21% of that to calculate how much she earns per week. And then you'll know that she's making regular deposits of $948.50 per week until she's 60, and you worked out at an interest rate of 4.2% per annum compounded monthly, and you worked out that she earned this much money, and then you know at 60 she deposits this money in a perpetuity. So how much does she get in payments if she deposited a perpetuity? And you can see it's 1558. So hopefully that helps you with answering this question.